Welcome to the Øredev keynote chats for 2025. I'm Frederick, and as usual, we're publishing our keynote speaker chats from the conference as short episodes. This year, we're releasing all 6 at once, Netflix season style. Also, as usual, links to each keynote and all other relevant information can be found in the show notes. They are in your podcast player right now, or at kodsnack.se, Kodsnack. Last up in this little series, just as it was in the conference, is David Cuartielles, one of the founders of Arduino. We ended up talking about how Arduino came to be and how you can get things manufactured by finding parts by weight in old factories. Oh, and shipping, of course. Shipping is a pain. Enjoy, and thanks again for listening to this little series. So, welcome to the smaller stage, David.
Okay, nice.
The pre-keynote. For those watching now, it's pre-keynote. For those listening later, they'll have a chance to watch the keynote before if they like. But I don't know what we're going to see. So I thought I'd ask about other things around it. So you were involved in starting Arduino?
Yeah.
Where did that come from? How did it happen?
Okay, yeah. So to start with, I'm a telecommunications engineer. So I specialize in microelectronics and algorithms for communication. And so I came to Malmo to work at the School of Arts and Communication as a teacher in programming to art and design students. And at some point, I started teaching electronics as well. And we made an electronics exhibition. We made a show that got a bit of press. And that got me an invitation to spend half a semester as a guest researcher at Ivrea, the Institute of Interaction Design Ivrea in Italy. It was a school that was financed by Telecom Italia back in the mid-2000s.
Yeah.
And during my stay there, I helped out with some projects with students and with a research project we had. And that gave birth to Arduino because we sat down and put together the ideas we had about how to create educational electronics. Me and the corresponding teacher there, it was Massimo Bansi, my partner. And that gave birth to Arduino. This collaboration, very much of a coincidence in a sense. Yeah.
Lucky coincidences.
Yeah.
And then it sort of just grew from there on its own, or have you been sort of driving it along? Or?
Yeah. I've been in the business since the beginning.
Yeah.
So I will very briefly talk about this in my talk later. But so what happened was that the Ivrea School of Design got cancelled at the end of that spring when I was... and we were creating this board that was going to be used in Malmo at the School of Arts and Design where I work at, and at Ivrea. And we decided that we had to spread the word about the design. The design was already open source to start with, but we became a bit more active in sending it to other people and sharing it, and it took a lot of traction. There were other systems at the time. It was an emerging thing, this thing of having educational electronics at a fair price. And the big difference was that in our system, all the blocks of the system were open source. And people considered that an advantage because they could hack it in multiple ways.
Yeah.
And so we kept on doing this for 5 years. There's like making boards, not being paid, until we decided that we had to make a company out of it because we were working many, many extra hours every day.
Yeah.
And we tried to make a company that really worked from the beginning. We sold a lot of boards. It was not designed to be $1 billion company back then, but it became something like that in the end.
Yeah. Yeah, it's fun when things take a life of their own like that.
Yeah. I mean, the moment you take an idea and you make it into a company, you also have to accept that companies are entities that are designed to have some kind of a life, because then money comes in place and personal expectations come in place, and then also employees' expectations come in place. The community expectations definitely has a lot of weight.
Yeah.
And then the company is a mix of all of these things together, And Arduino is definitely a company with the voice of the community has a lot of weight. They have a lot to say. And so this entity, I mean, being a single person, you no longer command it. You might be the one that plants the seed, but then once it takes its own life, you just see it grow, and you can decide to go follow it and be with it or not. So some of our co-founding members, they didn't have a chance to continue with us. For example, Dave Mellis, one of the partners, he moved to work for Autodesk. He's one of the main Autodesk software engineers and team leads and stuff. While some of us who were closer to like where the factories were and so on could stay on board for a longer time.
Yeah, I mean, just figuring out how to get something manufactured seems like a big adventure in its own. But I guess
and especially in Europe, where we don't really have a lot of factories any longer.
Exactly.
So what happens is that the area of Ivrea or the Piedmont in Italy, where we created the first Arduino board, is an area where the Olivetti used to be. So there is a lot of these old factories that used to be part of Olivetti or collaborate with Olivetti. And there were like a lot of workshops, there were warehouses with components. Like the first batch of Arduino boards, the reason why they have a 60 megahertz clock is because we found a place where we could buy them by the weight. So typically a clock would cost like €1, and we bought like 100 clocks for €10 or something. It was ridiculous. So, and it was because there was this old lady had a whole warehouse with all components that we used to make printers for Olivetti. And so we bought clocks, we bought some of the connectors there, and so on. So that had a strong influence in the original design decisions. It was availability of stuff. You know, it's like, I need this kind of like connector. Oh, they have 50 of this here. Let's make it with this one. Instead of thinking, oh, which one will be compatible with the future, kinds of boards. But that changed over time, right? Like now boards have to have USB-C, or they have to host different types of like power supplies and so on. But the beginning was really driven by this ecosystem of existing old factories and warehouses. And I think it's very different from what happens, for example, in Sweden, because Malmö, for example, here we had the Flextronics factory. Many people don't know this, but down there by the Västerhamnen, where World Trade Center is, there used to be a Flextronics factory. But all of that got lost, that facility, and they didn't have that many side businesses that were providing them with parts or anything like that. So for that reason, the moment the factory disappeared, that whole thing disappeared. But the similar ecosystem from the 70s, 80s, like Olivetti, had a lot of side factories and small workshops that were providing with stuff, and those still exist in Italy. So if you go to the north of Italy, you can find a lot of these places where to manufacture things.
It's such a nice. It's almost like a film idea, find this dusty place and you sweep it away and you find lots of
it's kind of like
hidden
that,
treasures.
So there's a bunch of funny stories. Like we don't own any factories at Arduino. We collaborate with factories. So we are a software company in a sense, and we have our things, our machines that we create that we put in factories, and they test the quality of the production. I will again talk about this in my talk, but it's like. So we can kind of like hijack any factory. But we decided to work with the factories in the Piedmont because they've been very loyal to us for many years. So in particular, there's one factory where the owner, as a hobby, he fixes old ambulances.
Wow.
So he collects ambulances. But his real job is to make boards for Arduino. It's his only job right now. So we make like 5,000 to 10,000 boards a day in his factory. And it's like 12 or 13 people working for him. So we built our warehouse just next door, because all of the boards come out, go to our warehouse, and they're shipped to all over the world.
Oh, it's so nice. It makes me happy just thinking about it.
But
building up a little bit of
it is not that hard. The thing is, okay, I'm talking shit here. It is very hard. It's very hard to make a company and so on, but you have to really trust people who have the experience of making the things, because nowadays you have this guy that has his factory. He's an expert in putting components on boards. If he tells you this component should be a little bit more to the right, you should listen to that person. Because he sees his robot going like all the time, right? So he knows how to do things. So I think we also need to think about this kind of collaborations and not think that while manufacturing is a commodity right now, being on top of the factory actually gives you a competitive advantage. So you have the chance to be at the factory and look at the production, makes things a lot better.
And I feel like it's easy to feel that everything has to be on such a huge scale nowadays. And like there aren't any other options. But then I hear stuff like this, and I heard a few other people talk about like smaller scale manufacturing. It still exists. It's still out there.
Well, there's something I like to call the bootstrapping dilemma. It's a term that I coined for my lectures at the university, and it talks about the idea that when you're proposing a product, right? Let's say you want to do a Kickstarter of a product, right? if you get up to like a certain amount of customers, you can still do it by hand.
Yeah.
And you can keep a certain price because you don't charge for your own labor.
Yeah.
Because you're just happy this thing is going out. And maybe you want to have 10 for yourself, but you make 100.
Yeah.
And with the money for the other 90, you get yours for free, but you still have to work.
Yeah.
But then the tooling of a machine is not for free. Like setting up a machine to assemble components or to inject mold plastic or whatever, that costs money.
Yeah.
So there is a gray area between I do it for free versus a machine does it, where you scale up and it's cheap to make, where it's actually more expensive because you start to labor in your own costs.
Yeah.
Because you go like the price is like this, and it's not very high because I make it by hand.
Yeah.
Suddenly, when it's too much, I start losing money, so the cost is much higher. Yeah. And then when a machine comes in, then it goes down again. Yeah. So that area in between is a gray area you don't want to be in. Yeah. What's the bootstrapping dilemma, right? Yeah. Like I want to make this many, but if somebody orders like 10 more, then I'm losing money. So I don't want that. Oh, yeah. Because somebody needs to order one order of magnitude more before it gets cheap. Yeah. You know. And I've seen many projects dying because they didn't manage to be as successful as they could be, but also because they were too successful for just covering up basic needs. Yeah.
So I guess you need to build up some kind of buffer to be able to get over that.
Definitely. So I've seen so many Kickstarter projects, talking about Kickstarter in particular. Yeah. Like my recommendation is to go out when you are 100% sure the design is done. Don't pitch the idea because then there's a risk that the idea might fail. But if your design is done and you just have to like tell the manufacturing go, then you have already factored in your own work hours, you know, and then it's much easier to like succeed. Yeah. You know.
So is that the trickiest part of all, or?
Yeah, definitely. Yeah. I mean, I think it's trickier to get it right in terms of scaling than to get a good design out. Yeah. Because the engineering is something that you solve by working hard or by getting someone to help you, but making the economics of the product and shipping is a pain. You know?
Yeah, shipping seems like an adventure of its own.
No, at Arduino, for example, we have a guy from Hungary called Csaba, who is our logistics king. Mm-hmm. Like, no, you can tell him, I need this thing to be in Colombia tomorrow, and he will figure out a way.
Well, that's a superpower.
No, exactly,
Black Definitely. Magic.
I mean, he might as well just tell you, not tomorrow, but maybe Tuesday. Okay, I can do that.
It sounds impossible to me, but not
actually, right now it's a bit harder than 10 years ago. 10 years ago, I think we lived in a moment where it was very easy to ship anything anywhere. Yeah. Now there is other regulations, so... So everything is coming in place, like tariffs and other things are making it very complicated. But with Arduino, we still ship to almost every country in the world. You know, there's different ways to do it. Yeah. And we have distributors all over the place. So I think it's possible. Yeah. You know, the funny thing is that we are a very small company and we figured out the equation to have like 3 million customers, while the large companies, they waste millions of dollars and they can't figure it out. You know,
that's also kind of.
I guess because we were very hungry in supporting our community, and our community is everywhere. While maybe large companies, they have few larger customers and they only have to figure out how to get their stuff to a certain place. Oh yeah. So it's a different game.
Yeah, that makes sense. It's almost time for your keynote. Thank you so much.
Thank you so much.
Big thanks for listening to Kodsnack. If you want to support us, leave a review in your podcast player of choice, or just tell someone who might like the podcast about an episode. And don't forget, you can come hang out in our Slack channel. A link is in the sidebar right on our website at kodsnack.se. Once again, big thanks for listening. Talk to you later.
Let me put it this way, Mr. Raymer. The 9000 series is the most reliable computer ever made. No 9000 computer has ever made a mistake or distorted information. We are all, by any practical definition of the words, foolproof and incapable of error.